Okay, example 18 asks us to express 8x squared plus x plus 20 over x cubed plus 4x in terms of partial fractions. So we need to look at our denominator first. We have x cubed plus 4x. Now we need to factor this because of the way that we build fractions. So the thing that in this terms, we don't have a normal looking quadratic, but we do have something in common to both terms, which is x. So we get x times x squared plus 4. Now, this you could factor with imaginary numbers, but we're not going to do that. It's not going to help us. So we're just going to leave these two things as fractions here. Now, the way that this is going to set up overall is you're going to have one of the factors will get a denominator. So we'll start off a over x. Now, the other factor, this x squared plus 4, we have to create a numerator that is 1 degree less. So like you see, this is x to the first. This is like ax to the 0. It's 1 degree less. Now, here, since our degree is 2, we have to create a term that is 1 degree less. Now, just to account for every potential polynomial of the same type, what we're going to do is this is going to be called bx plus c over on this side, because we don't know that maybe this has an extra constant there, but we'll need to figure this. So basically what is happening here is just like when we add normal other fractions, if we were to have a times x squared plus 4 plus x times bx plus c, it's going to equal 8x squared plus x plus 20. So again, a times x squared plus 4 plus x times bx plus c equals our 8x squared plus x plus 20. Okay, so what we have to do is we want to start off and we want to try our best in order to figure out what our a value is first. So that's very, very key. So what we're going to do is we cannot pick an x value that makes this 0. We can make an x value that makes this 0, though, and that would be just 0. So if we plugged in the number 0, what we would get is a times 0 squared plus 4 plus 0 times b times 0 plus c equals 8 times 0 squared is 0 plus 0 plus 20. So this is just going to all equal 20. So this will get 4a equals 20 because this whole thing zeroes out. So equals 20. And we're going to get a to equal 5. Now the second part of this, we are going to use this a value of 5 to go forward and help try to figure out different numbers for us to use here. Okay, so we're going to plug in 1 in for x. And that's just to make things simple for us. Okay, because what's going to happen here is we're going to end up with simultaneous equations. So there's multiple ways we can solve that, but we just need to pick a number to multiply in. Now, we got a to be 5 already. And so now we plug in our blue part. So we're going to plug in things with 1 in it. So we get 1 squared plus 4 plus our x, which again we picked 1, times b times 1, which is just b, plus c, equals 8 times 1, which is 8, plus 1 plus 20. So over here, this is going to be 5 times 5, which is 25. This over here, we get b plus c. And this over here is going to be 29. So we're going to end up with b plus c equals 4. Now this is, this is like kind of equation number 1. So we're going to store that for later. Now, the next one that we're going to try, we're going to plug in -1. So these are just numbers that we can plug in that are small that'll help us get values of that'll give us an equation for B and C that isn't too large. You could pick any numbers that you want, and they would always work so long as you evaluate correctly. But this is what we're going to want to do. So again, we found that A was already 5. So we're going to get -1 squared plus 4 plus -1 times B times -1, which is -B plus C. And that equals, again, 8x squared, which is going to be 8, plus x, which is plus a -1, minus 1, and then plus 20. So from here, we're going to continue to evaluate. So 5 times, this is going to be 5, so we get 25. Then we have a -1 plus this, so this is going to be plus a b, and then minus a c, and that is going to give us 27. So we have b minus c is going to equal 2. So we have b plus c is 4, and b minus c is 2. So we can think about solving these equations in multiple ways. You can use kind of the addition method. So where like method 1, our addition method where we have b plus c equals 4. We have b minus c equals 2. Now, if we wanted to add these together, what would happen is the plus c and negative c would cancel. So if we added these together, b plus b is 2b, c plus negative c is 0, and 4 plus 2 is going to be 6. So we would get b to equal 3. We would then recursively go back in to one of these equations and say, okay, well, if b is 3, then we have 3 minus c is 2, and we would have c to equal 1. So this is one way for us to solve our equation. Now, another method, method 2, would be to create a matrix and use that matrix to solve. So, like in this case, we would have, to set this up, you have 1b, you have 1c, and you have the number 4, and you have 1b, and you have a -1c, and that equals 2. And then what we're going to do is we're going to run a row reduction, which is what we did. Now, if the numbers are more complicated, you may not want to do method 1. If it's easy, like method 1, you could figure that out fairly quickly in other ways. But let's say if you wanted to use the calculator as a reminder on how to do that, you would want to go to second matrix. You would want to create the matrix that we just did, which is, this is going to be a 2 by 3. You get 1 by 1 by 4. And you get a 1 by -1 by 2. And then you're gonna run a row reduction. So you go second matrix, you go over to math, down towards the bottom you'll see an option that says ref, and you're gonna run an ref on that matrix, and it's gonna tell you that one of the first column here, you have you have 1b plus 0 c's equals 3. So you get b to be 3 and c to be 1 as well. So you get b equals 3 and c equals 1. So you get the same way. Now, when we put this all back together in our main problem, what we're going to have is we have our a, we have our b, and we have our c. So we have a, we found a to be 5, we have our b to be 3, and we have our c to be 1. So all back together, we have 5 over x plus 3x plus 1 over x squared plus 4. And that is what our answer is going to be, broken down into partial fractions. So in the case where we have to have a squared denominator, in this case, like this, you would need to something that can't be factored any further, you're going to have to do this bx plus c mode, and then you'll end up having to use test points and systems of equations in order to solve the remainder.